All right, so we're working on our biconditional statements foldable. So we are on the front cover. It says, when a conditional statement and its converse, so a conditional like the if-then and its converse are both true, you can write them as a single biconditional statement. So the conditional would be when it says, if P then Q, and the converse is when it says if Q then P. So where we reverse the order. So if those are both true, then it can be written as P if and only if Q. Now let me show you that with some symbols. So the if then is shown as P arrow Q. That shows if P then Q. And the converse is Q arrow P. That means if Q then P. So what the symbols look like for a biconditional is P, then there's a double arrow Q, meaning it can go forwards and backwards. I also would like to note, if you could squeeze in on your foldable somewhere, if and only if can be abbreviated as IFF. If and only if. That's a common abbreviation for that. It's just to write IFF. Okay, so let's look at our example here. It says, if B is between A and C, then AB plus BC equals AC. It also works for the converse. If AB plus BC equals AC, then B is between A and C. This is our segment addition postulate. So we can combine it and write it as a biconditional. So we're going to start with the hypothesis. B is between A and C. So we're going to say B is between A and C. If and only if, I'm using the abbreviation, and then we need to do the conclusion. AB plus BC equals AC. So because they're both true, I can combine them and write them as an if and only if, which is a biconditional statement. Okay, so also take note that all of our geometry definitions, so all definitions can be rewritten as true biconditionals. So if it is a geometry definition, it's going to work both ways and they can be rewritten as true biconditionals. So for example, if you said if an angle is less than 90 degrees, then it is an acute angle. The converse would be if an angle is an acute angle, then it's less than 90 degrees. Both are true, so you could rewrite it and say an angle is less than 90 degrees if and only if it is an acute angle. Or an angle is an acute angle if and only if it is less than 90 degrees. And when you see if and only if, it means it works both ways. In the conditional, the if-then statement, and its converse are both true. All right, let's look inside the flap. So it says, whenever a theorem is investigated or proved in geometry, the converse also needs to be examined. So when both a theorem and its converse are true, it can be written as a biconditional. That's what we just talked about. So it says you can write a biconditional as two conditionals that are converses of each other. So let's look at this example. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. So this is a biconditional. So it's saying, hey, you can take that biconditional and you can write it as a conditional and its converse. So let's write it as a conditional, which is an if-then statement. So let's say if a number is divisible by 3, then the sum of its digits is divisible by 3. So then the converse would be if the sum of its digits is divisible by 3, then the number is divisible by 3. So what this was showing was how you can take a biconditional and write it as an if-then statement and a converse, where the front flap was showing how you could take an if-then statement and a converse and combine it to be a biconditional. So it's just showing that it goes in both directions. All right, so let's talk about good definitions in geometry. So a good definition is a statement that can help you identify or classify an object. So it has several components. First of all, it uses clearly understood terms. So we can't talk about an angle or two lines being perpendicular if we don't know what the word perpendicular means. So it uses terms we've already learned because we have to have knowledge of the words to have the definition make any sense. It must be precise. So basically, you should avoid words that are kind of general, that aren't exact. So such as, sorry, I'm getting messy here, large, sort of, and almost. A definition is not going to say, well, it's almost this measure. It's going to be very clearly defined. And then it should be reversible. So a good definition can be rewritten as a biconditional, which is an if and only if statement. Okay. So in the space under the check marks, I would like to do an example, all right? So here's my example. All right, let's use the definition of perpendicular lines. I'm going to use symbols because I use them a lot in geometry because we do so much writing. So perpendicular, that's the symbol for perpendicular. Perpendicular lines are two lines that intersect to form right angles. All right, so now the conditional, that's the if-then statement. So the conditional says if two lines are perpendicular, then they intersect to form two right angles. All right, let's do the converse. The converse is where we reverse the order. It's still an if then, it's just the order is reversed. So if two lines intersect to form two right angles, that's the angle symbol, then the two lines are perpendicular, or then they are perpendicular. All right, so we can use the definition. We can write it as an if-then statement. That's a conditional. We can write it as a converse, which is where we reverse the order. And we can write it as a biconditional statement. Okay, keep in mind, that's where we can go both directions. So we can do two lines are perpendicular if and only if, that's my abbreviation, if and only if they intersect to form two right angles. And that completes our foldable.